So let's go back to the plan here. Okay, so the plan for the last session here, so for the next hour and a bit, is we're going to cover a couple of different things. So the first half is basically going to be about, first maybe a little bit less than half is going to be about how you actually should invoke Scenic. We saw how you could use the command line tool. But for more realistic applications, you probably want to use a Python API so you can get data back out, you can control exactly how long things run, etc. So we'll talk about that first, and then we'll talk about how you actually interface Scenic to different simulators. So to start out with, talking about how we interface Scenic simulators, we have another Colab notebook for you. Using Scenic programmatically. So this is also linked to from the schedule. So this one I'll walk you through a little bit, and then we'll give you some time to work on it. So actually, maybe I'll just do it. So is there a way you can selectively turn off these lights? Oh, is it the glare kind of problem? Let's try. I mean, it's a minor issue, but let's see. That's better, actually. But now it's better? Oh, yeah. Yeah. Okay. Let's try that. Okay. So here's an example. Is this big enough to see in the back? Okay. All right. So here's an example showing the most important Scenic API. So there's a whole page in the documentation, which okay. So if you're in the documentation, down under language and tool reference, there's this using Scenic programmatically page, which has the detailed, like more detailed documentation on this thing. The collab is actually basically the same information as in here. So the first thing you would want to do with a Scenic scenario is compile it. And basically what Scenic does when you compile it is it interprets the syntax and it figures out what the distributions for all the objects in the scenario are. And the internal representation of all of those distributions is, along with the requirements for the scenario, is this scenario object. This is a Python class that has some information associated with it. You can introspect these. If you're interested in like analyzing Scenic scenarios to do some manipulations on them, that will be the subject of one of the breakout groups tomorrow. But for now, we can just treat this scenario object as an opaque thing. It just represents the compiled scenario. So if we go back here, the top level Scenic module has this function called scenario from string. So there are two functions you can use to compile Scenic scenarios. Scenario from string, which is mainly useful for debugging, like if you have a little program you want to put in there. Although if you're generating programs dynamically, you could use this too. There's also scenario from file, which opens a file. So here, for example, scenario from file, you can give it a path to the file you want to compile. And it has various arguments. Actually, both of these functions have various arguments, allowing you to customize the scenario a little bit. So I showed before, for instance, how you could take a generic driving scenario written for using our driving library and then run it in, say, Carla or SVM, etc. That's done by overriding which world model the scenario should use. So you could say, we use the generic driving model, but now I want you to use the Carla model, which is specific to Carla and will projects be running, etc. So that's what you could use this model parameter for it. But you can also do things like override global parameters in this scenario. This basically gives you a way to pass arguments into a Scenic program. If you want to do things like, say, here's a generic driving scenario that makes sense on any map. Let's run it on a different map. In fact, I don't think I showed that earlier, so let me just show that right now. So we saw earlier we could run like, here's, oops. Here was this OAS scenario 5 running in the Newtonian model simulator. So here it is. And it's like that. If we close this, you can use the command line option param, which is basically the same as this API argument params here to override parameter. So we can say, like, for the map, let's not use town 01, I think it's whichever one it's using. But the default, let's use different maps. So we can say, let's use the map town 05. And then we get it in different. So that's a simple way that you can basically control some details of the Scenic program without having to modify the code. It's by passing in overriding global parameters. Okay, so going back to the code snippet here. So I'm compiling this little blurb of Scenic code here. So we have a one-line scenario which just creates an object whose position is uniformly random, with an x coordinate being between 0 and 1, and a y coordinate between 1 and 2. So what this returns is a scenario object that represents the compiled scenario. And the main thing you can do with that is generate scenes. So the generate function, a method on a scenario returns a scene that is sampled. So now we have concrete values for all the properties of all the objects. And it also returns the number of iterations that were needed to generate that, which I'm not going to use here. So I just put this underscore. And this scene object you can then look at to get information about the scene you generate. So in particular, if you look at these, we go to scenario, here's the documentation. The scenario class, you can see it has this generate function. There's actually a batch version of that if you want to generate a large number of scenes at once. You see the generate function returns a scene and the number of iterations used. And if we look at documentation for scene, you can see the information that you can pull out here. So the main thing is you have a tuple of all the objects in the scene. But we've also tell you which one is the ego object, if one has been labeled ego. You can get a dictionary with all the global parameters, so things like time of day and weather that aren't associated with any particular object. Those can be defined as global parameters, and you can access the sample values for those here. And then also the workspace, which I think you saw in the collab, is basically just a way of saying which part of the space you can create objects in. So all of these are attributes of the scene object, which you can inspect. So here what I've done is I've said, let's look at the first object and its position. So if I run this, this is test.py. Getting out here the position of the car, which you can see, I'll make this bigger. You can see here the x coordinate is between 0 and 1, the y coordinate is between 1 and 2, and the z coordinate is 0. If we ran this again, we get some different thing because I wasn't setting a random seed here, so it's not going to be deterministic. Any questions so far? So if you want to look a little bit more into this here, I'll just do a bit live. Import Scenic. Let's compile this scenario. Just do this. sample a scene. So this is a scene object, and we can look at all of the information associated with it. So for example, there aren't any global parameters in this scenic program. We can look at the objects. There's just one object. Oops. Okay, so here you can actually see all the properties of this object. So I only specified the position, but there are a lot of other properties, like for example, here the height of the object is 1, because I didn't customize that, right? The velocity is 0, right? So these are all the properties. Some of these are internal to Scenic, but most of these are things, the ones that don't have the underscores, are things that you'll see documented in the syntax guide, where it has a list of all the properties that objects have. So there are properties like, if you want to allow this object to align with other objects, that sort of thing. Most of these here were not very interesting. They just have fixed values, which are the default values. But you can see position here has this particular value that was set. So these objects are actually just ordinary Python objects too. So you can introspect all of these things. So we can look, for example, at, let's call this OBJ. Then I can look at position, I could look at width, etc. So you can fill out all of these things. And in fact, as we'll see in the second half, like what a simulator interface does is basically take all this information and then call simulator APIs to create objects with these properties. So that's the basic functionality of Scenic's API for compiling scenarios and generating scenes. The other main thing you can do is run dynamic simulations, starting from a given scene. So for that, you need a simulator that you want to use. Here we can use the Newtonian simulator, because that doesn't require any heavy-duty simulator to be installed. So, for example, I can do, let's, oops. Okay, so I can make one of these. I can say, let's run a simulation starting from this scene. And let's do it for, say, max steps. Well, I won't be in that. So where's the window? Oh, you know what? I think I have rendering off by default. So let's do. There we go. This is a very uninteresting dynamic scenario because nothing happens in it, but it's running, right? So we can make this a little bit more interesting. Let's let's go. I've got rendering again. Oh. Okay, now it's moving. So just to give you an idea, right? So the general way that you use this, the simulate method, you can take the simulator. This is basically an object in Scenic that represents a connection to a particular simulator. So the Newtonian simulator is built in, but we also have like a Carla simulator class, which represents a connection to Carla. Same with Weebot simulator, etc. And you can ask it to run a simulation starting from a given scene. This one I didn't put any time limit or anything, so this is just going to run forever. But you have this simulate method has various options. Go down here to running dynamic simulations. The simulator.simulate method has various options. So like in this example here, we say, let's run for only 10 time steps. There's actually a huge number of options that this thing has. If you go to the documentation for this method, it describes all of them. So you can say how many steps, how many iterations of projection sampling, what time step do you want to use? Do you want to save data allowing this simulation to be replayed later, checking to see if there was any non-determinism in the simulator, etc. So we won't go through all of this, but this is another one of the main APIs you would use if you want to run dynamic simulations. And you'll get a chance to try this in the CodeLab also. Okay. The last thing that I'll just mention, you'll see this also in the CodeLab, is that Scenic can serialize scenes and simulations to relatively small sequences of bytes so that you can replay them later. So this is useful, for example, if maybe you have some pipeline which is running thousands of simulations over the weekend, you come back and in 3 of the simulations, something interesting happened. And now you want to run it again, but now rendering like a video so you can watch it and see what happens. Maybe you ran it in headless mode or something, so you weren't even bothering with the movie, right? So what you can do is you can have your code that's running these simulations check if something interesting happened, let's save that simulation to a file. And what will be in that file is basically all the random parameters that Scenic sampled. So then Scenic will let you replay from that file. And every time Scenic would choose a random value, it'll read it out of this file instead of picking it up. So then assuming that the simulator is deterministic, you'll get the exact same simulation. So basically, there's a pair of methods for turning scenes to bytes and back again, and turning simulations to bytes and back again. So you'll be able to play around with these in the CodeLab as well. And again, the main thing these are useful for is to allow you to save interesting simulations and then look at them again later on. Another thing you can use, actually, this is, I think this is used, I have to check, in the parallelization. So if you want to run like a lot of simulations at once, are we not using this yet?
We don't have that ability.
Okay, we're not using this yet. But one thing you could use it for is if you have like a cluster, you can run like many copies of Carla or something, or whatever your simulator is. You can have one node generating these things, send them over the network, serialize like this, reconstitute them on the local workers, and then run simulations there. So we actually do in Verify, which we'll talk about a little bit tomorrow, have the ability to run multiple copies of Carla in parallel, but it's not actually not using this. It's doing something more simplistic that has more overhead. Okay, so that gives you some idea about the Python API that we have. So what we'd like you to do now is try out this new notebook here. Go to this one. It basically recaps what I just described. It gives you a chance to try doing things like generating scenes in a loop until you find one that's interesting, something like that. And we'll also cover, I think I forgot to mention, how you can use the record statement that we talked about before to save interesting information. So you could say, like, let's save the distance between these 2 cars, and now run a lot of simulations to see what's the simulation where they got as close together as possible. Like, what was the closest to an accident that we got in this particular thing? Okay, so go ahead, and we'll be here if you have any questions.